Hey guys, this is Group 1 presenting the concept reverse engineering. In this topic, we'll talk about what is reverse engineering, the steps involved in constructing the process, the tools used, the case studies involved, and also let's look at some of the advantages and disadvantages of using reverse engineering. Okay, so what is reverse engineering? Reverse engineering in computer programming is a technique used to analyze the software in order to identify and understand the parts it's composed of. Meaning to say that we need to analyze the modules of the product it is composed of, and we also need to know the functionality and the requirements that is used for building a product. We're just retracing the steps in building a software that is lost, or we need to recover that. And the usual reasons for reverse engineering a piece of software are to recreate the program, to build something similar to it, or to exploit its weakness, or strengthen its defenses. For example, suppose you have an unexpected case. Suppose you have written a code in Java program and the program runs okay, but it gets deleted accidentally. So what do? How do you submit your project? There comes the reverse engineering. And let's look at the forward versus reverse engineering paradigm. As you can see, in the forward engineering, you go from requirements analysis, design and implementation, where you finally integrate your product, whereas in case of reverse engineering, it's the opposite of that, where you initially start from the implementation and go back up till requirements, where you discover the designs and the requirements which were initially done during the forward engineering, and what we can see and what we cannot see. In reverse engineering, we're not able to see everything that's done in forward engineering, like the design issues and the alternatives that were rejected while doing the forward engineering, and the ramification of the decisions, like the unexpected events that happened while doing the forward engineering. And but there's a common part where we actually get the existing design code when we retrace the steps in the reverse engineering, and we finally get our the design code or the final product code. Let's look at the reverse engineering in other fields. The principles employed by the reverse engineering concept are they are widespread, and they're also used in different fields other than software engineering, such as the entertainment field, automotive, consumer product, microchips, chemicals, electronic field, and also in mechanical designs. And as you can see in the example, there's a reverse engineering process of how you can make the iron box, the retrace the steps in designing the iron box. First, you look at the manual measurement of the iron box, then you create a 3D model of that, and inspect that iron box model with the actual physical model, and you create a manufacturing drawing, and finally you give it for manufacturing process. And each of these fields has adapted the concept to its own specific needs, and they have also developed particular instruments and technologies. Suppose in case of CAD technologies.
Scope and task of reverse engineering. Reverse engineering helps determine how a product works. For example, if you start working on an existing product in a new company, it is necessary for you to first understand what the product does, what design pattern it uses, what's the architecture it is built upon, and also the overall flow of the software. It helps you learn the ideas and the technologies that were used in developing the product. Through reverse engineering, a researcher can gather the technical data necessary for the documentation of the operation of a technology or component of a system. It is also useful when an existing documentation of a system for its design, production, operation or maintenance have certain shortcomings, and the original designers are not available to improve it. The information that is obtained from reverse engineering a software can be useful to recreate or recover a part of the software code that was lost. For example, if you have an existing system that you need to either improve or create a new version of, reverse engineering comes to your rescue. By reverse engineering an existing software, one can retrace the system from the implementation to the design and obtain the abstract representation of the system. This abstract representation can then be used as a base to re-implement the new and improved version of the software. Thus, reverse engineering facilitates software reuse.
Now we'll see some steps for reverse engineering. First, do the trade-offs. Check the feasibility of the new requirements. Do the trade-off between the required changes in the product and its implementation cost. Take a decision whether the new implementation cost is beneficial over the existing product or not. Second, make the predictions. According to you or your team, how is the current product working? Make some predictions on it. List out some design objectives too. Third, justify the observations. Justify the current working method of the product on basis of your observations, predictions, and product knowledge. Observations made here might not be correct, but it will get clear after disassembling of product. Fourth, disassemble the product. For software products, use disassembler which will convert machine language code into user readable format. It helps to understand systems architecture using generated components. From here, you can easily understand function call tree, cross-file references, modules usage, etc. For hardware products, understand the architecture by disassembling the product. Understand the mechanism from different components get after disassembling. As earlier said, you might here get some surprises from your initial observations and the actual implementation. Analyze the subsystem. Examine the subsystem, use decompiler, code walkthrough, use breakpoints, debugger to make your understanding clear. External libraries, references, complex computational logic are easily identifiable here in this phase and would be easily understandable and would be helpful for reassembling of the product. Reassemble and test the system. Implement or modify the new requirements. Performance improvement, bug fixes can be implemented in this phase. Test the newly written code by appropriate testing like smoke testing, regression testing, or sanity testing. Record the new observation results for operational and ergonomic functionalities and project the durability of the new implementation.
Documentation. Documentation is a set of documents that serve as a record and is the final step. In reverse engineering, documentation is used to keep a record of the changes made by the developer. You may include changes in architecture, semantic diagrams, control flow diagrams, changes made to the existing code, identify any refinements that might enhance product, upgrades and version changes done while reverse engineering, listing the previous existing flaws, success over those flaws, and so on. Documentation may not include all the details but should be able to highlight all the changes being made. However, the best document is the code itself. Documentation is also used to keep a track of the code structure, which can be further used when the product has to be reverse engineered in the future, making it easy for other developers too.
Reverse engineering tools are used to disassemble a program or code and try to get back the source code. Let us look at some of the tools. OLEDBG is one of the most popularly used tools. It is a 32-bit assembler level analyzing debugger for Microsoft Windows. Its prominence on binary code analysis makes it particularly useful in cases where the source is unavailable. Some of its features are: it has intuitive user interface, open architecture where many third-party plugins are available. It can be used to debug multi-threaded applications and also can be attached to running programs. It provides full support for Unicode and can also be used to set conditional logging, memory, and hardware breakpoints. It shows us fix-ups and can be used for dynamically tracing the stack frames. APK tool is a third-party tool that can be used for decoding resources to nearly original form and recreate them after making some adjustments. It is a tool for reverse engineering Android APK files. Its main features is that it helps with debugging small codes step by step and also helps with some of the repetitive codes. Distrom 3. Distrom 3 is a lightweight, easy to use and a fast decomposer library. Its main feature is it is one of the most fastest disassembling tool available. It disassembles the instructions in 16, 32 and 64-bit modes. The source code is very clean, readable, portable and is platform independent. It solely depends on C library and is also
backward compatible. Some of the other commonly used tools are Snowman. It is a tool to decompile native code to C or C++. Java Decompiler. It is used to decompile and analyze Java bytecode. Miasm. It is for Python. Dotpeak. It is used to decompile .NET assembly. We also have other tools such as Wireshark, BinNav, IdeaPro, BinWalk, etc.
We have seen how reverse engineering is applied on software code using various tools to trace back the binary code to the original source code. Reverse engineering is widely used to replicate the existing physical object with the help of computer aided technology. Two main applications are in the field of medicine and in the field of manufacturing aircraft parts. To understand the reverse engineering applied to real-world hardware products, I will consider the example of manufacturing the injection molds of a human foot prosthetics. It involves various steps as shown here. Preparation. Porous objects like human bone structure needs special lacquer to enable smooth scanning. Laser scanning, as shown in the figure, when the human original foot prosthetic is scanned, scanned point cloud appears. This is scan point cloud. To join all the points cloud, we use a process called triangulation which creates polygon mesh between the points. This is the point cloud and this is the polygon mesh. This is the CAD object which will be formed after the triangulation process. Surface generation. This involves considering all the detailed surface modulation on the object which are further used by CAM systems to design and manufacture products. It is a tedious process which requires precision and generates all kinds of surface variation on the object as shown here. This is the chart which gives us the detailed surface generation or the surface geometrics involved in CAD. Finally, to produce a physical model, the plane of separation between the top and the bottom layer must be specified. Here, this is a plane of separation, this white surface. This blue is the upper mold and the lower mold is present at the bottom, which cannot be seen here. This is the upper mold and this is the lower mold, which are joined or integrated to form the original foot prosthetic at the end. Later in the slides, we will see the pros and cons of the reverse engineering process. Thank you.
Advantages and disadvantages. Every process has its own advantages and disadvantages. The advantages and disadvantages of reverse engineering include 1. Oldies but goodies. It's no surprise when you want to use an old software and it doesn't work as it was designed to, or it may need improvements to be compatible with the new devices. Reverse engineering can be helpful to reuse the software by making changes to such good old softwares. Improving bugs. Softwares often have bugs that are improved over a period. These bugs may be encountered by the developer or the user, and fixing these bugs can improve the quality of the product. Reverse engineering can be used to improve these bugs in the code but may also add new bugs in this process. Time and cost. Designing a product from scratch may take longer than reverse engineering a product that has been built and only needs a fewer changes. Old softwares can be used and modified to save time and cost. Legality of reverse engineering. Every software is protected by its developer or organization to ensure it is protected from unauthorized usage to avoid misuse of its products. The basic legalities associated are copyright protection and patent protection. One can reverse engineer a product legally by negotiating with the original person a license to lend the idea, or by claiming that the changed product is not protected by patent. Software security. Software files are protected by developers to prevent unauthorized use of resources. This is achieved by encryption or obfuscation. Reverse engineering such software may be tough. Also, as there may be a lot of junk code get confused with. Conclusion. Reverse engineering makes the system structure better, creates new dimensions of system documentation, and makes it easier to understand. Reverse engineering a software helps systems betterment and evolution. However, there are particular limitations to the extent that a system can be improved by reverse engineering. The presentation talks about the basic steps and tools involved to reverse engineering and also gives a, a brief of what reverse engineering is and what can be achieved with it. Although there are a couple of other ways a software can be reverse engineered, one can find their own ways to reverse engineering software that works for them.